Hello, everyone, and welcome to this Actian webinar on turbocharging your Hadoop data lake to deliver operational insight. Today's presenters will be Scott Clinton, who is the President and CEO of SC Ventures. Scott will be the first presenter. He'll be followed by Emma McGrattan, who is Actian's Senior Vice President of Engineering. If you have questions, just to remind you that you can enter those using the Q&A function. If you have technical difficulties, have problems hearing us, you can let us know through the chat function. And the event is being recorded, and we'll send a recording to you after the event to share with your colleagues who couldn't make it today. With that, I'll hand over to Scott to get us started.
Thank you for the introduction, Pradeep. The Hadoop market over the last few years has been going through a massive transformation, driving companies to look at their existing investments and potentially modify their future data lake and analytics strategies. There have been three key changes across both the business and technology areas that are fueling this transformation. The first has been industry consolidation. Over the last few years, the Hadoop vendor choices have dwindled significantly. Both Cloudera and Hortonworks have come together and merged as a single entity. MapR has disappeared into HPE through acquisition, and with few other alternatives other than the public Apache open source project available, companies are changing the way that they're thinking about maximizing and expanding their investments around their Hadoop infrastructure. The second has been the adoption of object storage as a data lake alternative. With the growth in Amazon S3, Azure, and increasingly Google Cloud Storage, these object storage solutions are being adopted as data lake alternatives for certain use cases. For data that's being generated in the cloud, these are natural alternatives. However, object storage as a data lake alternative is also being adopted on-premise as well, with products and technologies such as Ceph Storage from Red Hat, Minio, and S3 compatible storage appliances like those from Cloudian, among others. The third change is the growth in cloud-hosted Hadoop. Today, there are a wider range of hosted and managed Hadoop offerings, promising to offload its complexity. Over the last year, we've seen Amazon EMR, Microsoft Azure HD Insight, and Google Dataproc grow from small-sized projects to mid-scale deployments, taking on a number of use cases for companies that were originally focused on traditional data lake infrastructure. In addition, a number of companies also self-host their own instances on cloud infrastructure or through an MSP partner. Cloudera recently stated publicly that nearly 20% of their customers are using cloud infrastructure in this way. So while Hadoop is not quite dead, as it may have been reported in the press, it is transforming through data lake modernization in a big way, which could be both time-consuming and expensive as an approach, as you really work to modernize these data infrastructures. And not all workloads are necessarily suited for the cloud. All this is to say that this renewed focus on data lake modernization, as companies look to this changing landscape, is an effort to try to balance between existing investments and future needs. Even with all these changes, investments continue to be made in Hadoop infrastructure. In 2018, the industry research group reported that $1.2 billion were spent on simply the applications and software infrastructure. This excludes any hardware or services. This continued investment is to make sure that the existing data lakes remain up and running and account for modest growth. It's projected that companies will continue to increase their spend to nearly $10 billion by 2024. IDC put the global spend for Hadoop and related infrastructure services at nearly $27 billion at the close of 2019, with projected growth focused on more hybrid cloud deployment and management scenarios. Even more urgently than maintaining their current investment and incremental growth, companies are working even harder to get more out of their existing data lake investments. Hadoop has had its challenges, both in its complexity and capabilities, that were primarily designed for batch-oriented, long-running processes on massive amounts of data. But the needs of companies have evolved, and the ability of the traditional Hadoop stack continue to limit what new use cases can be supported, especially when it comes to operational and real-time applications. Traditional Hadoop stacks on their own struggle to address many of today's new workload demands. Again, Hadoop was originally designed to support batch processing of massive amounts of data, not concurrent access by tens or hundreds of users, and struggles with real-time access and scaling concurrently. Hadoop can do updates, but they're eventually consistent. And while performance has improved over the years, it still means it is likely that real-time workloads end up operating on old data, which can result in drastically different outcomes, especially when fresh data is critical. Building applications on top of Hadoop with traditional tools requires unique and specialized expertise, which can be costly. And while the traditional Hadoop stack does provide a level of SQL support, it is often incomplete and can limit the effectiveness of your traditional analytics and BI tools. This lack of standard SQL can also limit application portability for applications across on-premise and cloud environments. These challenges together limit the use cases people can support with today's data lakes and traditional Hadoop stacks. COVID has also had a huge impact both in terms of our personal lives and in terms of digital transformation and the growth of analytics projects and organizations. For businesses and individuals, our reliance on technology and systems has skyrocketed, from personal communications on Zoom to e-commerce as our default and only buying option for many. If you're not already a digital-enabled business, COVID has unfortunately made digital transformation and analytics a sink or swim requirement. We completed a study just a couple of weeks ago where they had looked at COVID and the impact on digital transformation. In their study of global IT practitioners and leaders, they saw that the economic and low or no touch reality of COVID has brought dramatically accelerated digital transformation projects, in many cases shortening delivery by up to 5.3 years. This means that previously multi-year digital transformation projects have been given top priority. Long roadmaps have been compressed into very short timeframes. With the need to enable customer engagement and e-commerce capabilities, to manage the complexity of the supply chain changes and the realities of this low or no-touch economy we're all living in today, this has put a larger burden on digital transformation to ensure a company's operational effectiveness. Balancing digital transformation, businesses, and operational analytics projects and deployments have also accelerated in dramatic fashion. A McKinsey report that came out just last month, September 2020, looked at how operational analytics projects have also been accelerated. While many companies had plans to create new and expand existing operational analytics projects, there was not the business imperative and urgency in all cases. Again, COVID has changed this dramatically. In McKinsey's study, they saw analytics projects accelerate both in creation and delivery, in many cases to a matter of weeks from multi-month roadmaps and plans. While budgets have been prioritized, they're still limited. So COVID has really put a fine point on the fact that it's really time is of the essence, both for digital transformation and operational analytics projects. So let's discuss some potential solutions to get more out of your existing data lakes, balancing your budget constraints and the urgency to bring new workloads and use cases. One of the quickest ways to get more out of your existing Hadoop data lakes is with SQL acceleration solution, allowing you to make incremental investments without completely re-architecting your existing data lake and infrastructure while gaining a significant return. These solutions address many of the shortcomings of traditional Hadoop infrastructure that I talked about earlier. And this opens up the opportunity to deliver operational and real-time analytic use cases while lowering the costs of specialized programmers by making it possible to apply the pervasive knowledge of ANSI SQL with the same or greater return on execution speed. And while different SQL acceleration solutions take different approaches, all address the traditional Hadoop stack limitations in whole or in part. So depending upon the solution you choose, you can enable a range of use cases. For example, allowing you to operate and analyze data in real time through the standard set of analytics tools used today, without Hadoop speed and compatibility compromises. With SQL acceleration, you can also bridge both transactional and operational analytics through real hybrid transactional and analytic processing, or HTAP, where the traditional Hadoop stack often stumbles at scale. Some solutions use pre-indexing and processing of data to accelerate query response through overlays of OLAP cubes. But this also comes with some of the traditional limitations of cubes, especially if you need to analyze fresh or regularly updated data. Cubes create pools of stale data, but can result in shorter query response times. SQL acceleration can be highly effective, especially for complex queries across large data sets involving many concurrent users. Hadoop was designed for batch and not concurrency. And these SQL acceleration solutions can also speed up model training for machine learning and AI workloads. And many of these solutions can also help support data virtualization use cases, allowing you to query across multiple data sources and file types, including Spark, ORC, and Parquet, while combining with enterprise applications, SaaS, and other traditional data sources. Actian Vector for Hadoop is just such a SQL acceleration solution that can help you get more out of your existing data lake. In fact, Blur Research recently published a new report looking at SQL acceleration solutions and their ability to help you get more out of your existing data lakes. This is an update to their 2018 market report for SQL Hadoop engines and takes a fresh look at both the current set of vendors for SQL acceleration on Hadoop and reviews 3 primary categories and how each vendor delivers. The 3 primary categories of vendor solutions they looked at included general purpose offerings that consist of a layer on top of Hadoop. These are typically ports of SQL engines from conventional database and data warehousing environments. Second are products that had been constructed as a specialized layer on top of Hadoop, that are products that have been designed for a specific purpose rather than merely providing a generic SQL capability. And third are products that have been specifically engineered into, as opposed on top of, Hadoop. These actually fall into a couple of subcategories: products that have been specifically designed from the outset for Hadoop, and then products that have been ported from other environments but have been re-engineered specifically for Hadoop. In the report, Blur chose Actian Vector for Hadoop, stating that of all these vendors, Actian Vector for Hadoop is perhaps the most interesting, thanks to its deep integration into the Hadoop infrastructure. Blur also highlighted the importance that any solution you invest in needs to be able to support or provide a path to the cloud. In today's increasingly cloud-centric IT environments, many workloads that are today on-premise are on a path to the cloud. Many will also remain hybrid in nature as well. This is critical to future-proofing your applications and data infrastructure. Having a standardized SQL approach and products that can support that cloud journey will help ensure easy migration of applications and workloads to and from the cloud and cloud data warehouses. Having a SQL acceleration on Hadoop that bridges those key areas becomes a critical factor in helping to both optimize your architectural approach to your Hadoop data lake modernization, as well as provide a solution today that can start to bring new workloads onto the Hadoop platform. I'd like to hand it over to Emma to help us understand more in detail about how Actian Vector for Hadoop is uniquely suited for helping modernize your existing Hadoop data lakes through SQL acceleration. Emma?
Great. Thanks, Scott. Pleasure. So my name is Emma McGrattan, Senior Vice President for Engineering here at Actian, responsible for delivering on our analytics portfolio. What I'm going to focus on is the vector for Hadoop that Scott just mentioned, that Blur recognizes provides for a deep integration with Hadoop. And there's a couple of areas of focus for us. The first is performance. And we built the solution to sit on top of the Hadoop architecture and deliver the type of performance that one would typically expect in an enterprise data warehouse. So that, high performance, handling very complex queries for large user volumes is something that we've cracked the code on. We also recognize the fact that when HDFS was first developed, nobody envisioned it providing for things like updates, right? So being able to make corrections within your data, to have singleton inserts, updates, and deletes. And we felt that if we're delivering on EDW-like capabilities, that providing support for fully ACID transactions, including updating transactions, was important. And we did this in a way that doesn't impact the performance of running queries. So we'll get to that in a minute. We also, as I've mentioned, we look at concurrency. It's important to us because what we see is that every organization that's deploying infrastructure that enables their their user base or their employee base to make decisions about their customers want access to all of the data, right? So they'll typically want to provide everybody within the organization. It might be a copy of Tableau or it might be a copy of Excel. It's whatever tool makes sense for their business, but they want to provide them with access to all of the data to make the best decisions that they can for the business. Being ACID, we believe, is important, particularly because Actian is very much focused in financial services and healthcare. And if you're in financial services and you say, I want to move $1,000 from my checking account to my savings account, as soon as that money goes missing from my checking account, I want that to be part of the balance on my savings account. I don't want those two accounts to eventually become consistent. I want that to become consistent at the moment that I hit return, right? Once that transaction starts. So being ACID compliant, we felt was important for the market that we were going after, because there's two reasons for that. One is that those that are used to EDW type workloads expect ACID compliance. And then the second is that we wanted to do something different with Hadoop. We wanted to turn Hadoop into a platform that could meet the expectations of those with large data volumes that were transitioning from more traditional technologies. Maybe it was SQL Server, maybe it was Oracle database, and that they'd used in a standalone Windows or Linux environment, but to get those capabilities on Hadoop and to be able to scale with the ease that Hadoop can scale. And then finally, security. Again, mentioning the fact that we're very much targeting healthcare and financial services. Securing that data is hugely important, and that's an area in which we've provided a lot of capabilities. So what is Vector for Hadoop? So it's an MPP database. So it scales out across a number of nodes in your Hadoop cluster. It uses HDFS for that scaling. So we have the ability to partition the data across your file system and then spin up as many nodes as it makes sense to provide for the query volume that you expect inside the business. So you can scale in and out as the business needs change. We have support for Cloudera and the Apache Hadoop distributions, as well as the cloud Hadoop deployments, right? So it may be that it's HD Insight, it may be Amazon EMR, it might be Google Dataproc. It was important to us that as people transition to the cloud and they wanted to leverage the Hadoop skills and applications they'd built up within their organization on the cloud, that we provided the ability to do that. We provide better than linear scalability. So the performance that we can deliver is consistent, and as you add more nodes into the environment, you see the benefit of those nodes right away. And we've got a proof point on that a little later. And we integrate with Spark. I mean, Spark's amazing for data movement, right? It parallelizes that data movement. We can bring data into the cluster and egress data from the cluster through Spark, and there frankly is no faster way of moving data around. And then we looked at the fact that the organizations that we're talking to have already made an investment in analytics, right? They're probably using tools like Tableau or Looker or Qlik, Cognos, whatever it may be, right? And what we wanted to do was to make sure that that investment that they'd made in reports and dashboards and applications using those technologies should transition very easily over to Vector for Hadoop. It really should just be a matter of moving the data into Vector for Hadoop and then changing the endpoint for the dashboard or the report so that it connects to Vector for Hadoop instead of whatever they were using previously. And the entire application should function in exactly the same way that it did previously, except it's probably going to be a bit faster. So how much faster? So we employed a third party to conduct a benchmark comparing our performance with that of Hawk, Spark SQL, Impala, and Hive. Impala and Hive are the two that we come across most frequently. The other two we encountered in particular sales situations, so decided it was interesting to add them to this performance comparison. And what you see represented on the screen here is the time it took to execute 22 queries, which make up the TPCH benchmark. So TPC is an industry body that defines benchmarks for measuring the performance of different data-related workloads. TPCH is a decision support workload. It's got a mix of medium and very complex queries that make up this benchmark. And what you'll see here is that we ran all 22 queries against the technologies I've mentioned. What's represented in the graph is how many times faster Vector for Hadoop was than those other technologies. So Vector sits on this one line, and what you'll see in the graph is, queries like if we come down here, we'll see that we're up around almost 1,000 times slower than Vector for Hadoop to complete these queries. Here's one here that unfortunately query 9 is in the wrong place in the graph, but Hive was over 1,000 times slower than Vector for Hadoop in completing the queries. Now, what we have seen, the graph can be a little difficult to interpret because it's on a logarithmic scale here. So this represents 1 to 10 times faster, 10 to 100, and 100 to 1,000. I'm sorry, I said query 9 there, where I obviously meant query 5. So if we, if we look to the table below the graph, what you'll see is the actual timings for the queries, and this is something that's much easier to read. So for query 1, Vector H, Vector for Hadoop, completed this query in 1.34 seconds. If we look at Impala, it took 585 seconds to complete that same query, and for Hive, it took 490 seconds. So imagine that query represents a report that you're waiting for, and today for Actian is the last day of the quarter. I know other companies will have different quarter end dates, but you can imagine waiting 585 seconds to get the latest report as opposed to 1 second, right? And the impact that might have on the business. It might be something like, a customer wants a discount. You want to be able to calculate what the maximum discount that you can provide is. You want to get those answers really quickly. And Vector for Hadoop gives you the ability to get those answers really quickly. And as I mentioned previously, we provide for linear scalability. So as the volumes of data changes and you add more nodes into the environment, you'll see that capability continue to deliver this type of performance regardless of the data size that you're working with. This TPC-H benchmark also has an update stream, and the idea behind it is that it's representing 3 years worth of data, and that you will add 1 new day's worth of data into your data lake, and you will age out the oldest day's worth of data from there. So it's a rolling 3-year window across the data that you're working with. So in aging out 1 day and adding in another day, the performance for Actian Vector for Hadoop as well as Hive are represented in the very bottom of the graph. So for Vector for Hadoop, that same query still completes in less than 2 seconds. For Hive, that query time went from 490 seconds, now it's up to 608 seconds. So across all 22 queries, after we had refreshed the data by bringing in a new day and aging out the oldest day, the query time for Actian Vector for Hadoop was about the same, right? Across all the 22 queries, our performance now is 99.3% of what it was previously. For Hive, the time taken to execute all 22 queries is now 138.2% of what it was previously. So almost 40% slower. And think about it, you're updating 1 day of 3 years, right? So a really small subset of the data has changed here, but the performance impact for updates for Hive is quite significant. The reason we haven't reflected numbers for Hawk, Spark SQL, and Impala is that they cannot provide the capability required for that refresh stream on HDFS. And they do have other mechanisms for doing it. For instance, for Impala, you would use the Kudu file system for it, but we felt like it was an apples for apples comparison with everybody working on HDFS, since that's the most popular platform for Hadoop deployments. So what makes us so fast? So there's 6 things that contribute to the performance that Vector for Hadoop delivers. The first is where the name comes from. This is vectorization and vectorized processing. So you can think of a vector as an array of values. And in a traditional technology that's performing analytics queries on Hadoop, what they'll do is they'll go record at a time through the record set. And if you're doing something like an average, right, it will sum them and divide by the number of records. With Vector for Hadoop, we actually operate on a vector or an array of values of 1,000 values at a time is typical. So when you're doing that summation, you're getting the sum on 1,000 values in the time it takes for our competitors to add 2 values together. So significantly faster because of this vectorized processing. Vectorized processing is something that is provided in any Intel or AMD x86 64 CPU. So you don't need any specialized equipment for this. This will run on something as simple as a laptop and give you the type of performance that you would have expected of a high-end server. We recognize the fact that the modern CPU has a few megs of onboard cache. So we're using the on-chip cache as our execution memory. So again, if we look at the query engines on Hadoop that we're competing with here on the performance side of things, they're typically using DRAM for execution memory, and getting that data from DRAM into the CPU takes time. We said, well, we can shortcut that by actually using the CPU cache is our execution memory. So the graph here represents the much greater throughput that you get in CPU cache when compared with disk or DRAM, and the significantly more data that can be processed. So as well as processing it very quickly, you've got much larger data volumes that can be processed there. We have built the solution for multi-core parallelism. So recognizing the fact that Hadoop clusters today will have a lot of cores within them, and that can be achieved by a few very beefy nodes or a large number of kind of lower end nodes. And what we've done with Vector for Hadoop is provided for the maximum parallelization as makes sense for each query that we're executing. So we'll divide the query up into parts. Each of those parts gets executed across the cluster in the available cores. The results of each of those parts comes together, and the result gets provided back. So for very complex queries, they can sometimes be broken down into maybe it's 1,000 cores that can be used to execute the query, and we'll scale this based upon the resources that have been allocated for the Vector for Hadoop product. Ours is a pure column store. So many of our competitors, both on and off Hadoop, claim columnar storage, and they only claim it obviously because it's true. But what they're talking about is they store the data on disk as columns. How they manipulate that data once it's inside the engine is typically that they convert it into rows, and then they deal with rows of data at a time. We said it makes much more sense when you're dealing with analytics technologies to have a pure columnar approach. So our data is always represented as columns, and we operate in those columns. And if you think about it, if you're doing something like, maybe you're analyzing your sales for a quarter, and what you'll typically want to do is to just compute on certain columns within that, right? So it might be you're trying to get the average price paid for a particular product SKU, right? So you're looking at the column will be the price column, right? And maybe you're also looking at the SKU column where you're doing some selectivity on that. It might be that you want to get the average discount that was applied. You may be doing something much more complicated like a k-means, but typically you're doing analysis on individual columns and not on rows. So if you're dealing with rows, there's a lot of data that you're carrying around that you're not using for analysis purposes. If you're dealing with columns, you're just going very targeted against the columns that are part of that analysis that you're performing. We've tried to make this really simple. So we automatically create storage indexes. So as we're writing data out to disk, we keep track of that data. So data is written to disk in files, and within those files you have blocks, and for each block that we're writing out to disk, we keep track of the minimum and maximum value that we're writing to that block. And then when we're solving a query, we're able to tell, oh, the values that I'm looking for are within that range, so I'll read that block. The value that I'm looking for is not within those ranges, so we ignore those blocks. So it makes for very efficient I/O and allows us to very quickly narrow down which of the blocks that are going to help us in solving the query. And we use, most database technologies use smart compression algorithms. What we want to be able to do is to identify the algorithm that makes sense for the type of data that we're dealing with. So we're storing the data as columns, and typically when you're dealing with columnar data, all of the data within that column is of the same type. So it might be a date column, right? So everything within that is represented as a date. It might be that it's money, and you're dealing with floating point for your currency representation. It may be first name or last name, and then you're dealing with character strings. Each of those types of data will compress very differently depending upon the algorithm that you're using. So we look at the data and we make a decision as to what's the best algorithm from a performance perspective for that data. So you don't need to know anything about the compression that's being used. We've got some smart algorithms that will figure out what makes sense for the data, and typically we'll see about a 5-to-1 compression ratio as we write that data out to disk. So quite impressive, actually, given that our focus isn't on minimizing our footprint on disk, but rather on the speed of compression and decompression. So I mentioned earlier that one of our differentiators is the ability to provide for update support on HDFS, and where this became important to us was our first customer for Vector for Hadoop was a large global bank, and they had deployed risk applications on top of Vector for Hadoop. And on the first day where they drilled this through to production, they had one of their traders in foreign exchange had made a mistake in choosing the currency symbol for a trade that they had conducted. They chose the Canadian symbol, currency symbol, instead of the Chinese currency symbol, and it completely changed the risk characteristics of that trade, right? Canadian currency, I guess, is seen as more stable than Chinese currency. So the risk profile was changed by that mistake. They needed to correct that in the original trading system. They then generated a report that needs to get signed off on, but that change needs to be reflected inside the data within Vector for Hadoop so that they can rerun the day's reports on risk and showing that they hadn't gone within certain thresholds on that in risk. There's a lot of very stringent rules, and those rules have with them fines if you violate the rules or regulations. So it was really important that they were able to make this fix, generate the reports, and show that they hadn't violated the rules around risk exposure. And that was enabled by the fact that Vector for Hadoop supports updating data in real time. So they were able to make the fix, reflect the fix, rerun the report, and it was almost like it never happened, except that their CRO needs to sign off on it. So, I mentioned on the previous slide where we had the benchmarking numbers that when Hive, which is the only other solution that I can provide for updates on HDFS, refreshes a very small subset of the data that they are querying, their performance impact is quite significant. The performance was already miserable, and now it gets 38% more miserable. So this is something that we're quite proud of and that really differentiates us. The other point here around differentiation is that we looked at the file formats that were very popular on Hadoop. So Parquet, ORC were the two that we came up against quite frequently. And we looked to see if there was something that we could do to speed them up. And when we looked at the underlying structures, they have limitations that we weren't able to overcome. So we use our own proprietary file format on Hadoop. We write the data out as a series of vectors, so a series of arrays written to disk in a proprietary file format. But what we did in defining that file format was to look at the query time, that was important to us. Being able to secure the data was really important to us, and minimizing the amount of I/O that was required to satisfy a query was really important to us. So on the first graph represented on the screen here is query time taken to complete an individual query for Impala running Parquet, Presto with Parquet, Presto with ORC, and Vector H. The yellow that's represented in the graphs here that you can barely see is the time in seconds taken to run a query in Actian Vector for Hadoop. And what you'll see is that we're down here around 1.6 seconds, ORC file format 58.8, and then Parquet, depending upon whether it's Impala or Presto running against it, we're still up around the 50-second mark. So significantly faster for query time. And then to the right in this graph is showing how we can use those min-max indexes, the automatic storage indexes that I mentioned previously, to our advantage to minimize the amount of data that we have to read to solve a query. So what you'll see here is that for ORC, the entire file has to be read to get the data that you need, even if the data that you're querying is a very small subset of that file. So their amount of data that needs to be read is consistently 3.7. You come down to the Vector for Hadoop number here, and it's 0.06, where we're just very targeted in what we have to read and write. So it's part of what makes us as fast as we are. I mentioned that this file format also has serious implications with respect to security. The file format that we've chosen gives us the ability to provide for things like column level encryption. So skipping straight to number 5 here, if you want to secure a specific column within your table, so maybe it's social security number, maybe it's a credit card number, you can secure that using column level encryption. So encrypt just that column, and then there's no impact on the rest rest of the data within your table. So that's a big differentiator. The next is number 6 on here, this dynamic data masking. And what that provides you with the ability to do is to take sensitive information, let's say it's a credit card number, and you can define a mask whereby you say, I want all of the digits but the last 4 to be masked by the letter X, so that any unauthorized user that's seeing this data will see the masked data except for the last 4 digits. Authorized users get to see the data in its raw format or its more natural format, but you've got the ability to do that dynamic data masking with Actian Vector for Hadoop. Other things that we provide for is user authentication. So this means that you confirm that the user who's accessing the system is who they say they are. And we can do that using Kerberos or Active Directory or any pluggable authentication mechanism. So user authentication was important. Discretionary access control gives you the ability to decide who can access what within the database. So you can specify at the user, the group, or the role level who has read, write, update, delete access to your various database objects. Role separation gives us the ability to keep a database administrator out of sensitive data. So typically the use case for that would be if you had sensitive customer data. You want to make sure that your database administrator, while they're responsible for things like system backups and so on, that they can't actually get into the underlying data, even if they tried very hard. Security auditing and security alarms. This is the ability to audit everything that's happening within the database, whether it's successful or not. So let's say we have a rogue hospital employee who's trying to access patient information. You could take a look through the discretionary access control would keep them out of patient information that they weren't supposed to see. But the fact that they have been snooping around in the system is something that you can set a security alarm off to let you know that it's happened, and then you can go into the security audit logs to see what they did while they were in there or what they attempted to do, right? So as I mentioned, it will record everything, whether it was successful or not, so you can see exactly what was going on in the system at the time. What's represented on here is the architecture of the solution. I don't want to go into too much detail here, but essentially to the top and to the left, what you'll see is that we can support all of the standard tools that are used, whether they're open source or proprietary tools, for issuing SQL queries into the Vector for Hadoop solution. We will then process that query as it comes in, and it could be ODBC or JDBC, Python, Ruby, R, doesn't matter what it is. So we'll process that query. We pass that query execution plan written as an algebra over to a high-speed analytics engine called our X100 engine. Comes from the name, the name comes from the fact that it was designed to be 100 times faster than anybody else that's out there, and you've seen that in the numbers that we've shared with you. And then this is running on our leader node. We then will break down the work that's required to solve this query and pass it over to all of the worker nodes that are sitting on top of your Hadoop nodes within the cluster. So this parallelization happens. The query gets executed very quickly on these worker nodes or data nodes. They pass their part of the result set back up to this leader node, and then the results get passed back up to the calling application. So the data is distributed across HDFS. These X100 engines then query their portion of the data. We call it partitions. So they're querying the partitions that they're responsible for. They pass their part of the result set back. Those result sets get pulled together and passed back up to the calling application. In building it, we wanted to be sure that when people had already made investments in analytic infrastructure, that would all just work seamlessly with this Vector for Hadoop solution. There's no need to write any MapReduce jobs. There's no need for very complex rework in existing applications. We wanted those things to work off the shelf by just changing the endpoint where they're getting their data from, and that should be a very straightforward operation. Calling out some of the other capabilities that we provide. So we've built this to be, to support the enterprise. So we provide for full ANSI support. We are very much standards focused, and in fact, Actian chairs the board that defines the SQL language. So there's an ISO board that defines the language that all of the database vendors agree to support, and we actually are very much focused on that. And that allows us to provide support for people that have written applications for other technologies and to just deploy those unchanged against Actian Vector for Hadoop. I've talked already about how important we believe it is to be ACID compliant. You want to see the results of a change immediately. So, when I gave that use case where the bank needed to make a correction to a trade that happened in their foreign exchange desk that day, as soon as you make that change, you want that reflected, every time you query the data beyond that point. So it was important for us to be ACID compliant. The update capability is very unique, right? Not only the ability to provide for these updates within Hadoop, but to do it in a way that doesn't impact the performance of running queries or subsequent queries, right? So this is something that we have a couple of patents on and that we're very proud of. The database security features were really important to us, particularly the ability to provide for things like column level encryption and to provide for dynamic data masking. That was all important, and it's something that our customers have expected, off of Hadoop, and we thought, well, why should expectations change as we deliver on Hadoop? So Vector for Hadoop provides all of those security capabilities. Under the performance set of features, went through the 6 things that contribute to making the performance what it is, and we're really focused on delivering performance like you will never see matched on Hadoop. So, I showed you in that table that we had earlier that we can be anything up to 1,000 times faster than our competitors in solving queries on Hadoop. And those are standard SQL queries, right, running against standard structured data, and they're representative of a decision support workload, and that's seen as being mixed or complex. You'll see our query times down around the 1 second mark. We've designed it for high concurrency. One of the things that we had seen on Hadoop was that a lot of projects were being done in the lab with a small number of users, and we're seeing success. But then as they were deployed across the enterprise and the number of users and the data volumes would grow quite significantly, many of our competitors had problems delivering on performance then. Vector for Hadoop is designed to deliver high performance for large numbers of users. We have customers that'll be running thousands of users against a Vector for Hadoop instance, and they all expect sub-second responses for the types of queries that they're running. The query optimizer that's built into Vector for Hadoop, and the query optimizer is the smartest part of the engine when it comes to figuring out the best way of solving a query. So our query optimizer is a rules-based, a cost-based optimizer, and you can it was initially developed in academia and has been something that we've worked on for a number of years to deliver on very high performance, as you see from the numbers that we can deliver. So a mature query planner and a very fast optimizer. What we do is we look at the cost of things like CPU, memory, cache, and internode communication, and come up with the quickest and most efficient way of executing the parallel query when all of those factors are taken into account. We typically like to have Vector for Hadoop deployed on a set of nodes that are not shared, that are dedicated to running Vector for Hadoop. But if you had a cluster where you wanted to mix analytics with your ETL jobs, that is something that we can support, and we recommend in that scenario that you use Yarn. And the reason we recommend that is that Vector for Hadoop can be a bit of a beast when it comes to resource consumption. So if you wanted to make sure that your ETL jobs weren't going to get starved of CPU and memory, you could actually ring fence the Vector for Hadoop environment to say, this is the CPU and memory allocation that I want to allocate for Vector for Hadoop, and then obviously we'll run within the context of Yarn and honor the specifications that you've laid down. We do, in building this also for Yarn, Yarn was designed initially for for short-running jobs. I mean, that's typically MapReduce jobs. You set the job, it runs, it comes back, and it's done. And with a database technology, this is something that you want to start and rarely have to take down for scheduled maintenance. So long-running jobs wasn't an initial design point for Yarn. So one of the things that we had to factor into our Yarn implementation was the ability to preempt the workloads. The resource allocation for our workload. And what I mean by that is, let's say you said, I want Vector for Hadoop to have 80% of the resources at most of the time. But when I'm doing end of quarter processing and I want, have a lot of new data coming into the system, I then want to be able to scale Vector for Hadoop back just to 40% of the resources on the machine. So you can scale that back to 40%. When you're done with that ETL processing and you want to scale Vector for Hadoop back up to 80% of the resources, we can do that. And that shrinking and growing of our Yarn container is something that's done dynamically. You don't need to shut down and restart the database instance for that. So that Yarn preemption is, again, I think quite different and quite unique. On the open side of things, we today have Vector for Hadoop available for the AWS and Azure public cloud environments, and that can be delivered as a product where you can deploy Vector for Hadoop in those clouds, or as a fully managed service. Our fully managed service is called Avalanche, and we are in the process of delivering that on Google Cloud right now. In fact, we have an early adopter program for Actian Avalanche for Google Cloud if you're interested. You could take Vector for Hadoop and deploy it in Google Dataproc, and that all works just fine. But the managed service is something that we're seeing a lot of interest in. And if you'd like to participate in that, get in touch and we'd be happy to add you to that early access program. We've designed this to be Hadoop distribution agnostic, and Scott mentioned up front there's been a lot of consolidation in the Hadoop market with the merger of Hortonworks and Cloudera with MapR. There's Apache Hadoop, and then there's the distros that are running in the public clouds. We certify Vector for Hadoop across a wide variety of Hadoop distributions because we want you to be able to deploy this wherever it makes sense for your business. We've built Vector for Hadoop for the collaborative architecture that we often see on Hadoop. So being able to integrate with Spark, being able to, so we have within Vector for Hadoop what we call an external tables capability. So you can actually register an external file as a table within Vector for Hadoop, and you can join the data from that file with your Vector for Hadoop data, and it, for all intents and purposes, it looks like just another table inside Vector for Hadoop, and that's enabled by Spark. So lots of parts of the Hadoop ecosystem that can augment the capabilities of Vector for Hadoop, and we've built it specifically for that. And that external table capability also kind of ties in with this open data formats, and we've got the ability, maybe you want to keep your data as Parquet files, but you want to query it from within the context of Vector for Hadoop, we provide for the ability to do that. So just to wrap it up with a couple of customer use cases. This first one is Expandium. They provide for real-time network analysis and optimization. So for telco providers, and then one of the things that they saw was that a lot of what happens within a telecommunications network is reflected within crane or rail networks as well. So they have support for both. So on the telecom side of things, the example they gave me was that maybe there's a football match that's starting or a soccer match that's starting, and typically these stadiums are outside of the city. Typically, there's not a lot of people out around the stadium except for the time leading up to the match and as the match is happening, and they need to be able to switch network capability over to the area around the stadium for the period of that game that's happening. Sometimes there's lead up. They'll see a lot of activity, people taking photos, posting them on Instagram, and so on. And they need to be able to handle that workload. And then when the match is over, people very quickly disperse from that area, and now they need to move that network capacity back to wherever it makes sense for that to be deployed. So where it's most popular, this network analysis, or not most popular, I should say, but where it provides the most value, right, is where you've got these bursts of activity where you need to be able to meet a sudden demand for network capacity, and then, you know, if that demand then dissipates, to take that network capacity and redeploy it where it makes sense. Same with trains, I imagine, right? So again, taking that same scenario where you have an event that's happening, you'll see a lot more customers for the trains. They, you know, service that event, and then your network capacity on your train network would go back to moving the train stock around and so on. Would go back to whatever the normal use case is. So to do this, they are doing this constant analysis for their customers. They have 20 million cell phone customers on this network that they're managing for a French mobile company. They have a 10-day rolling window of 40 billion transactions for those 20 million customers. So a lot of phone activity getting analyzed, making sure that the capacity is where it needs to be, and being able to do all of this with Vector for Hadoop. This next one is a bank. Actually, this is the example customer that I spoke of earlier. This is one of the top 5 European banks. They grew a lot in the 90s and in the early 2000s through acquisitions of other banks. And they wound up in a situation where they had over 30 different risk applications sitting on Oracle databases. And what they wanted to be able to do was to have a single place where they could go to analyze risk across all of the different risk profiles and portfolios that they had to manage. So I'm not sure if you're very familiar with financial services and risk, but essentially you can think of it as, it's almost like betting, right? So if I'm conducting a very risky bet with my money, I probably want something that's a very safe bet at the same time to kind of balance that thing out. So when you're dealing with things like foreign exchange risk, you'll have some very risky trades, you'll have some not so risky trades. Mortgages, right? You'll have some risky mortgages. Maybe I've lost my job through COVID, and my bill paying record's not great. I'll be paying a much higher interest rate on my mortgage than somebody that has a much steadier job and a better employment record, or whatever. They may get a lower mortgage rate. But so they're measuring this risk across all of these different risk applications, and they wanted to have a single place where they could go to look at how risk had been exposed across the business over the course of the day. They wanted to do that because there's actually a legal requirement, BCBS 239, that requires that at the end of the trading day, they have a 1-hour window in which to report back to the regulators what the risk exposure looked like for the business over the course of that particular day. So we started this with a proof of concept. And the right-hand side of the slide here, what you see is the goals for this proof of concept and then what we actually achieved with them. So the first goal was to be able to actually load 2 billion risk data points into the Vector for Hadoop cluster over the course of the business day, which was just a 6-hour window. What they wanted to make sure was that at the end of the trading day, everything was reflected within the data lake, right? So we had 6 hours to load this. We managed to load it all in 1 hour and 40 minutes. So 333,000 records loaded per second. They then needed to be able to do a full day aggregation in 30 seconds. And what we showed them was that we could deliver on that in 6 seconds on a 5-node cluster. And when they grew that cluster to 10 nodes, that timing came down to 2 seconds. So better than linear scalability exhibited there. They needed to do some filtered aggregations across hierarchy dimensions on 1 million data points, and that needed to return in less than 15 seconds, and we got sub-second response time there. They had a second was the level of granularity on their timer, so we know it was sub-second, but down into the milliseconds, I'm sure. They're generating 2 billion risk data points a day, and they wanted us to show that we could store 80 days worth of data, and that would be 160 billion rows, and we showed that. And we went to 100 days, which was 200 billion rows, and we demonstrated linear scaling as we grew that data set. The next thing was that they said, well, we're doing 2 billion risk data points a day, but we could continue to grow, and we could enter new markets, and we could wind up to, 10 billion rows per day that we need to analyze. And we needed to demonstrate that if that were to happen, they just needed to scale the cluster, and we could show that linear scalability. And we did that, right? So that's how we went from that 5-node cluster to the 10-node cluster, demonstrating that we could handle up to 10 billion rows per day without breaking a sweat. Then they want to be able to do drill up and drill down, providing the ability to do ad hoc querying against the data set in less than 2 seconds, and we were very easily able to show we could do that in less than a second. So other points on here include the fact that they needed that risk report to run within 28 seconds. I'm not sure where that number came from. I'm sorry, we completed it in 28 seconds. The 3 hours was their target, right? They had 3 hours that the business said they needed that report within, and we were able to do that quite handily. So being able to handle a data workload of this size and this importance to the bank was something that we're very proud to be able to deliver, and delighted with the performance that we could achieve. So those are just a few of our customers. If you visit Actian.com, you'll see we have a customer section on the website where we've got a lot of success stories for customers with Vector for Hadoop that you can kind of dig into understand more details on. So that is the end of the slides that we had prepared for you. We saw a couple of questions popping up during the session, and we have answered those through the chat function here. But if you think of any questions that you would like us to answer for you, or if you're interested in getting your hands on Vector for Hadoop, or learning more about it, or seeing a demonstration, please do get in touch, because we'd be delighted to help you with any of your needs relating to any Actian technologies. But for me, most interestingly right now, Vector for Hadoop, and then Actian Avalanche, that fully managed service that's built on top of Vector for Hadoop. So over to you, Pradeep.
Great, thank you, Emma. That was a great presentation, and thank you, Scott, for the opening. And thank you, everyone, for actually showing up and enjoying the presentation, we hope. And we will send out a on-demand replay link to the presentation for anyone who may have missed it. With that, we'll close. Thank you very much. Bye-bye.